Happy National Sweater Day. Okay? And I even reminded myself yesterday, tomorrow's sweater day, you gotta wear a sweater. And then I looked at a sweater today, and then I grabbed this instead. So, it happens. Okay? Alright? So, upcoming things going on this week. Today we're going to get into the law of cosines. Tomorrow we'll get into more of the law of cosines with some more application type stuff. And then on Friday, you will take a formative. Okay? So formative on Friday. And then next week, Thursday, you'll have your test on law of sines, law of cosines. Okay? Alright? So, with that being said, let's get into it. Now, this is the proof of the law of cosines. Okay? And how you go about proving the law of cosines is you put a point somewhere in quadrant number 1. Okay? We'll call that point B, somewhere in quadrant number 1. Okay? If then we label the sides, if we label the sides A, B, and C, then side B would be along the x-axis. That's crucial because it makes our math a little easier because it gives us a 0 for a y value for all of those points. Okay? A is at the origin. That gives us 2 more zeros for x and for y. Okay? And then utilizing some right triangle trig, if we were to drop in the height here, then y really is the height of that triangle. And so then we can find the coordinates of point B by using SOHCAHTOA. And then, so let me show you here in green. So this would be A, this would be B, and this would be my side Y. So then the sine here of angle A is going to be Y over C. So that's how we get that, what Y is, C times the sine of A. Then we can also say that this side here is x, and we could say the cosine of angle A is x over c. And so x would be c cosine of A, which that gives us then the coordinates of point B. Horizontal distance would be x, which is c cosine of A. Vertical distance would be y, which is c sine of A. Okay. What we're trying to find here is we are trying to find this side length of A, the opposite side from angle A. We're trying to find that side length. So we can use the distance formula. The distance formula is just basically the Pythagorean theorem manipulated a little bit for you. Okay? And so the distance here from point A, the distance formula is going to be the square root of A minus C. Oops, hold on, tap the brakes. I got too many of the same letters going on here. I don't like that. I'm trying to make it as not muddy as possible. So it would be A, or so it would be this part, go here, this minus this quantity squared. Actually, why am I writing it? It's literally right here. It's literally right there. I don't know why I was going to write it. So it would be the x part of B minus the x part of C quantity squared plus the y part of B minus the y part of C quantity squared is that brown distance A. Then what we can do is we can square both sides. to get rid of the radical then, let's see, let's go way down here. This one here squared is going to be c cosine of A minus B times c cosine of A minus B. So I have to multiply these two together. That gets me my c squared cosine squared of A. Then I have to multiply these two together. That gets me my minus BC cosine of A. Then I have to multiply these two together. That gets me a second minus BC cosine of A. So that's where this minus 2 BC cosine of A comes from. And then negative B times negative B is positive B squared. The nice part about subtracting by 0 is that this part basically just goes away. So when I square that one, then it's just c squared sine squared. This one here doesn't have anything else, so it just gets locked in as that one. B squared is just B squared. But then the other two both have a C squared in them. So what we can do is we can factor out this C squared right here and right here, and that would leave me then C squared times the quantity cosine squared plus sine squared, both of angle A. What is cosine squared of angle A plus sine squared of angle A? It's 1. It's the hammer. Okay? That's the hammer. So then this becomes 1, and then therefore we get this wonderful thing that we call the law of the cosines. Today, we're going to teach you 2 different ways to remember the law of cosines. Okay? There's the Schmeling way, and there's the Linzmeier way. Doesn't matter which way you remember it. What matters is that you do remember it. Okay? All right? So that's one of them. There are 3 different laws of cosines. I shouldn't say 3 different laws of cosines. There are 3 laws of cosines depending upon which angle you have. Me personally, I memorized the law of cosines way back when I was a little Linz, okay? By knowing that the same letter was the bookends. Okay? So it's the same letter as the bookends, and then the other 2 are squared and multiplied on the inside. So I remember it as this b squared is going to be a squared because that's my other letter. C squared is my other letter. Minus 2ac cosine of b, so that b is on the bookends in this particular case. C squared would then be what? A squared, yep. Plus b squared, yep. Minus 2ab cosine of c. Okay. And with the letters that you start with. In the middle is the other 2. Okay. Schmeling's method is he likes this one. You just lock in an angle, okay? And then they're basically the same, okay? It's just that the opposite side squared is the 2 adjacent sides because you don't have a hypotenuse because you're not dealing with a right triangle. So you got the 2 adjacent sides squared. 2 times the adjacents, cosine of the angle. Okay. Again, don't care how you memorize it, but you do have to memorize it by Friday. Okay? Because there is a law of cosines question on the formative. Okay? All right? In the law of sines, we solved for the smallest angle first. In the law of cosines, we solve for the largest angle first. And that comes back to our discussion that we had first semester about where the inverses are. Inverse sine was the right side of the unit circle. We don't deal with negative angles in the triangle, so that left us with just inverse sine being able to find angles in quadrant number 1, which would be acute angles only, which means you got to find the smallest one first. Okay? Inverse cosine was the top half of the unit circle, which allows us to find not only acute angles, but obtuse angles as well. Okay? So therefore, that's why we find the biggest one first, because one of the nice things is that, hold on, I want to shade, and I want to pull down, pull over. Now I can go. There we go. I don't want it in there yet. Okay. Oops, bad G. Bad N. Come on, let's learn how to spell. You only have to use the law of cosines once. Okay? Because once you use the law of cosines, you will have a complete fraction. So then you can switch back to the law of sines. Okay? So just so you know, you only have to use the law of cosines once. And we use it to find the biggest angle first. The nice part about the law of cosines, there is no ambiguous case. Okay? There's no ambiguous cases in the law of cosines. Okay? You either get a triangle or you don't get a triangle. Okay? And I'll teach you how you wouldn't get a triangle here momentarily. The other thing is you're going to use the law of cosines when you're dealing with a side angle side or a side 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 case. So if you're given two angles and two sides and their included angle, then you're dealing with the law of cosines case. If you're given three sides of a triangle, that's a law of cosines case, because you don't have that complete fraction for the law of sines. Okay? Now, there is one thing, it's not an ambiguous case, but there is one thing that we need to talk about, and that is that side case. In a triangle, in order for a triangle to be formed, the two shorter sides of the triangle, the sum of those two sides, has to be bigger than the third side. Okay? Because if it's not, if we're dealing with triangles and they're not bigger, if the sum of, so I'm going to use my forearms here as my two other sides, and then across my shoulders as the third side. Okay? If they're not, if the sum isn't big enough, then they never meet. Okay? But if, now shorten up the distance here, but if the distance is, then they meet and they would form between my elbows and my fingertips would be the triangle. Okay? Or if they meet over here, or if they meet over here, etc. Okay? If they're the same, then you just get a line segment. Okay? So it has to be bigger. Can't be equal to, has to be bigger on that sum. Okay? Using the law of cosines would get you, in a side angle side case, would get you that third side right there, and that opens up your law of sines. In the side case, one of your angles would get, you would solve it using for one of the angles. Okay? Let's do it. So, starting with a picture never hurts, especially in these problems, because after today, your homework packet's wide open, and we just all kind of mixed them in. We didn't put law of sine problems together. We didn't put law of cosine problems together. We kind of mixed them all in. So starting with a picture is very beneficial for you, because then that would give you a better visual representation of which law you need to use. So we've got angle A at 35 degrees, which means then that this is side A. We've got angle B, could be in either spot, doesn't matter, but that length, that side length, is 15. Angle C would be the other one, and that side length is 30. Side angle side case, yes? Okay. So I would start with the law of cosines. A squared is equal to B squared plus C squared minus 2BC cosine of A. When you go to type it in your calculator, I strongly encourage you to add a set of parentheses around those. Okay? So then this is going to be A squared is equal to 15 squared plus 30 squared minus 2 times 15 times 30 times the cosine of 35. And that is just a straight up calculator input. And the nice part about modern day calculators is you can just put it right in as is. 15 squared plus 30 squared minus 2 times 15 times 30 times the cosine of 35. I get here that a squared is 387.76316, but that's a squared, so how do I get just a? Square root both sides. That gives me a is 19.69170. Okay. So now we have side A. Which angle should we solve for next? Angle B? Why B? It's small. It's going to be the smaller of the two. Yep. Okay. So we're going to solve for angle B next. So now I'm going to say that the sine of 35 degrees divided by 19.69170 is equal to the sine of angle B all over 15. So that is inverse sine of I get angle B here is 25.90736 degrees. So then angle C would be 180 degrees minus 35 degrees minus that. I only went to 5. Okay. Only went to 5, so we'll go 4 there. So, angle A was 35 degrees. Side A was 19.692. Angle B was 25.907 degrees. side B was 15. Angle C was 119.093 degrees. Side C was 30. Good? All right. Try that one. So Tony must find the distance from A to B on opposite sides of a lake. He locates a point C that is 860 feet from point A and 175 feet from point B. He measures the angle at C to be 78 degrees. Find the distance A to B. Law of cosines case. So my distance AB squared is going to be 860 squared plus 175 squared minus 2 times 860 times 175 times the cosine of 78 degrees. That gives me 707,643.58106 for AB squared. So distance AB then would be 841.216 feet. Yes? Okay. So in the side case, here is where we first need to make sure that it is a triangle. Okay? So I need to take my two shorter sides. I should make this check on a side case. My two shorter sides are 5 and 7, and that has to be bigger than 9. 5 plus 7 is 12. Is 12 bigger than 9? Yes, it is a triangle. It is a valid triangle. Now we can find lengths, or find angles, I should say. Okay? Which angle are we going to find first? Angle A, because it's the biggest one. It's opposite the longest side. So we're going to find angle A. So that means I'm going to be using A squared is equal to B squared plus C squared minus 2BC cosine of A. So A squared would be 9. 9 squared would be 81. B squared would be 7 squared. 7 squared is 49. C squared is 5 squared, which is 25. 2 times 7 is 14. Sorry, I sneezed, Billy. Excuse me. 2 times 7 is 14. Times 5 is 70. So then this would be minus 70 cosine of A. $81 minus 49 is 32. Minus 25 is 7. So 7 equals negative 70 cosine of A. Divide both sides by negative 70 gives me negative 1/10 is the cosine of A. So angle A would be the inverse cosine of negative 1/10. I get angle A here is 95.73917 degrees. Next, I would utilize the law of sines. Now I can say that the sine of 95.73917 degrees divided by side 9 is equal to, which angle do you want to find next? Which angle should we find? Should be C, right? Okay. But does it really matter? No, doesn't matter in this case because we had an obtuse angle for our first one, so they're both going to be acute, so it doesn't matter. But let's get into that mind habit of finding the smallest one first. So let's say sine of C all over 5. So then the sine of angle C is going to be 5 times the sine of 95.73917 degrees, all divided by 9, which means that angle C is going to be the inverse sine of all of that. I get 33.55731 degrees. And then angle B I get angle B here as 50.7035.2. degrees. So, all told, we had angle A is 95.739 degrees. Side A was 9. Angle B was 50.704 degrees. Side B was 7. Angle C is 33.557 degrees. Side C was 5. Okay. Good times. You now have the ability to do all of your homework packet. Because your homework packet only deals with the law of sines and the law of cosines, you have now learned all of it and can do it all. Okay?